Imagine a plate of steel being acted upon by a bunch of forces. How would you find the acceleration of the center of mass, ag, and the angular acceleration, alpha, of the plate? Well, it turns out that the acceleration of the center of mass of the plate is given by the sum of F is equal to mag. And this formula surprisingly says quite a lot. The sum of F is the net force on the rigid body in newtons. M is the total mass of the rigid body in kilograms, and ag is the acceleration of the center of mass of the rigid body in meters per second squared. It also turns out that the sum of mg is equal to ig alpha, where the sum of mg is the net moment about g in Newton meters, ig is the moment of inertia about g in kilograms meters squared, and alpha is the angular acceleration of the rigid body in radians per second squared. Now these two formulas are all we need to calculate the movement of any rigid body, no matter where the forces are acting. However, it also turns out that there is yet another formula which can be used to find alpha. If it's true that point O is a fixed point, pinning the rigid body in place, then this formula can be used. The sum of MO is equal to IO alpha, where the sum of MO is the sum of moments about point O in Newton meters, IO is the moment of inertia about O in kilograms meters squared, and alpha is the angular acceleration of the rigid body in radians per second squared.